Hey, everybody. Welcome to Data Engineers Lunch. We had a cancellation for a speaker from Quix. So I'm going to step in and give a talk on something that I've actually given a talk in the Cassandra world, but I think it's valuable to see the concepts in general in data engineering, because actually what I'm going to be talking about is data operations. We're going to go ahead and show our intro deck here to get started. There we go. All right. Yeah, welcome to Data Engineers Lunch number 82. Today we're going to be talking about automating Cassandra operations with Apache Airflow. Thank you, Akwi, for being a co-organizer. We always need speakers, members, and sponsors. Please reach out to Akwi at akwi.us. We're part of a diverse group of people in actually various different types of meetups in the data community DC. We'd love to have you come and speak. Our group includes, our community includes a lot of different groups, such as data visualization, data science, statistical seminars. And what we cover here, we cover the get your shit together problem, how to get data all together, processed, cleaned up for people to use. And we have a lot of fun. We're not limited to any technology or tool or cloud. If you are new, please introduce yourself in the Google chat and the YouTube chat. And if you have a question, you can always ask it there. If you want to share something, you can also mention it there. Just be polite. Our company now helps our customers build global data platforms for their national or global brand. And we have some sponsors such as GW, and some local sponsors in the area here, and of course, organizational sponsors for all of Data Community DC. So if you are looking for a job or offering work, you can drop it in the chat. If you have a meetup you want to advertise, we are always hiring full or part-time in terms of data platform operators, engineers, architects. There are lots of events at meetup.com/data-community-DC. We have weekly data engineers lunch on Mondays, and we have a Cassandra lunch on Thursdays. You can check those out at Anant US events. And if you're interested, we have a runbook available for Cassandra on logs, configs, and 80 patterns. So it wasn't too long ago that when Cassandra came out, it started to have good friendships with technologies like Spark and Kafka, and then later on Kubernetes, because it started to, all of those components, they scale horizontally. And recently, there's another tool in the toolkit, Apache Airflow, that can bring together the Spark aspect in Cassandra, ETL, cleaning data, getting data in and out. And Spark is pretty much the only game in town in terms of large scale data in and out from systems that are big. For example, we wanted to get data in from S3 into Cassandra, or from Cassandra out to S3, or you wanted to synchronize two different Cassandra instances that are not all together in a cluster. You would be able to do that using Spark, and Airflow makes that easier. Airflow and Spark are part of our toolkit, our framework of tools we would like to help our clients with. Our framework generally includes things that are distributed, real-time, extendable and open, automatable, and can be monitored and managed using APIs. And the reason we like using Airflow and Spark are because, well, first of all, they're both Apache projects, they're both open source, but they also have a big community of users around the world. And in the data world, Spark has been around for a while. Airflow is relatively new, but it's very powerful, especially when you use it with Spark. I'm not necessarily going to be able to do a code demonstration. If I am, that'll be great. Otherwise, I'm just going to focus on explaining, how Airflow works with Spark, or how it can work with Spark to make things like ETL a lot easier, and then explain how we delete data in Cassandra with some Spark example, and then explain how we can operationalize that with Airflow. And I'll also leave you with, I think there are 6 or 7 Git pod examples where you can try this stuff out without ever downloading any of this stuff. So stay tuned. As I mentioned, we help platform owners build, reach beyond the potential to serve a global customer base that demands everything now. And we do that by designing, building, and managing platforms so that they can focus on thinking and growing big. Our customer base are made up of primarily nowadays global and national brands that help people in various technology, or not technology, various areas of industry, both consumers and businesses. But one thing they do have in common is that they're global, or they have a need to move information and process information at a global scale. The way we do that is we help our customers manage the challenges from going from a business problem to a platform design problem to a how do we build that platform with the right technologies to how do we manage that platform going forward. We help them with our solutions, which basically gear around our framework, which is our selected toolkit, our approach to managing platforms, and of course a playbook in terms of how do we design it, how do we manage it. It's more from a management perspective. Business platforms are made up of lots and lots of different components, and at the center of a business platform, it's not actually business intelligence. Actually, behind this blue icon, it says data and analytics. And I wish I had the other slide here, but business platforms have different constituents or users. So we have customers, platforms, partners, and employees. And then recently, we would say things are also part of that. And each of these areas are served, or each of these users or things are served by, let's say, information systems for employees, partner ecosystems for partners, customer experience platforms for customers, and then IoT systems or for IoT platforms for things. And in the middle is data and analytics. And data and analytics is what brings all this stuff together, whether it's to move information between systems, whether it's to collect data, bring it together so that people can do BI. Ultimately, the data storage and the processing of information is the center or the heart of a business platform. And we focus on the modern open data platforms. And so our playbook is primarily on how to build cloud neutral platforms, or doesn't even have to be a cloud, it could be in your own physical data center. And people say, well, why don't you use the cloud? Well, because data storage and data processing are expensive at scale. And so some people might have hybrid design where they have some on-premise and they have some cloud. Now, I mentioned Cassandra here because, well, I like using Cassandra, but it offers us a way to replicate data across data centers magically, whether that data center is in the cloud or on-premise, or between different clouds. And we can be doing different things on that data simultaneously, which, normally in the monolithic data world, or if you're dealing with data warehouses, you do your transactional systems in one, and you do your analytical processes on another type of database. With Cassandra, you can kind of get both best of both worlds. But yet, there's still a need to get data in and out of Cassandra. At scale, at speed, where that's where we need to think about using, let's say, Spark. Right? In a data platform, there are many components. One of the most important components is a scheduler, which is of the things that are not automatically being done via stream or stream processing. We need to have a way to track when things are done. And so the more mature a data platform is, the more likely it's going to have all of these components, but a mature data platform will have not all of their jobs being managed by cron, but rather by a system that manages those jobs. So Airflow is one of the schedulers, and that's why we're going to talk about it today. In the distributed, real-time component world, there's lots of things that do similar things. So, there's lots of databases that are distributed now. There's lots of distributed compute systems out there. But when we combine something like, let's say, Cassandra with Spark, and there's another tool called Presto, we can do a lot of cool stuff that we weren't able to do by each one of these alone. Like, for example, Presto needs some data to do SQL joins on. Cassandra by itself can't do joins. So when you connect Presto and Cassandra, you can do joins across tables. Spark allows you to do more than just joins across tables in Cassandra. It allows you to do machine learning if you want. It allows you to do computations at scale if you want. And when you put all these things together, you have a system that's not quite a relational database, but it's not trying to be. But you can basically have a transactional database, and you can have kind of like a data warehouse at the same time. So where does Airflow come in, right? If you could just use this to do what you need, where does Airflow come in? Airflow comes in where you need to do things for people on a recurring basis. Like, I want this data exported and copied into Postgres, or I want this data coming from a JSON file set. I want to take this JSON file set and parse it and make it into data tables, data frames, and I want to put that into Cassandra. So that's where Spark is it's like a Swiss Army knife. It's got a lot of really cool stuff in it. And to do that, on a recurring basis, we need something like Airflow. So, there's lots of tools out there, right? I just showed you kind of the distributed toolkit, and it's not even close to where the things out there. There's lots of stuff out there in the data and AI landscape. So how do you choose, right? Why would we choose Airflow, right? This is the layer for just open source tools in a larger ecosystem. Here's a cloud data foundations data and AI landscape. Again, lots of really cool tools. Why would we use one over the other? Well, one way is to just go Google, hey, what is a reference architecture for an open data platform? And lots of people have their opinions on this. And what you'll see is many of them have the same icons. Like, for example, I'm not talking about dbt today, but this one has dbt, this one has dbt, and this one has dbt. Airflow, similarly, is very popular. And what I mean to say popular, it means that there's a community of people that use it. And in the open source world, if there's no community around an open source product, you probably shouldn't use it. Even though, let's say, Airflow is backed by a company called Astronomer. They have in fact, this is Astronomer right here. This is a variant of Airflow. Even though there is a company backing it, if, let's say, that company stops backing it, then what happens, right? Well, with Airflow, not only is a company like Astronomer backing it, Google has Google Composer, which is their version of Airflow. Amazon has something called MWAA, Managed Workflows with Apache Airflow, right? And I think maybe Azure or Microsoft may be getting into it as well. So this is just our process. We go do the research, we see what people are using and say, okay, why are they using this? And then when we go dig deeper, we realize why a tool is good or why it's bad, or if it's too overhyped, for example, right? And the other thing is, like, what can be used by more people, right? So, for example, Airflow is a competitor to Prefect. Prefect is relatively new. It's got a lot of traction in it. Why would we pick Airflow? Well, because there's just way more users of Airflow. There's a lot more code examples to use with Airflow. Same thing with, let's say, Spark versus Beam or Flink. Beam can run on top of Spark, and Beam can actually run on top of Flink. But Beam and Flink generally have come from the streaming world. A lot more people do batch processing right now, and still, even though we want everybody to do real-time streaming, more people do batch than they do streaming. So Spark would be a starter kit of doing batch processing, and it offers you stream processing. So in our framework, we take all these tools that we find, and we taxonomize or categorize them in our taxonomy. Where does this thing fit in, right? What is this purpose? What is the purpose of this tool? Where does it fit in? And sometimes tools don't really fit into one particular category. But we are able to put things into a strategy. So we got open source, Google native, let's say, is a strategy. AWS native would be a strategy. And so in our open source strategy, lots of tools in the modern open data platform, they fit in there. And That doesn't mean that every company needs to use everything open source. It's just that if they don't have anything else, we would say go ahead and use it, especially if there's a technology company that's backing an open source tool, that's even better. But if you're on Google or if you're on AWS, then you would be able to just use something that they're offering. So if you're on Google, you can use Google Composer for Airflow. Now, it's expensive, relatively speaking, but if you've got the money, pay for it. Let them manage it for you. If you're using Google, use Google Dataproc. It's their version of Elastic MapReduce from Amazon. It's got basically all the components of Hadoop, including Spark. Why reinvent the wheel? Let them do it for you. But having an open core or an open data platform, you can make those choices. You can say, I'm going to use Spark, but I'm going to use Google Dataproc because I'm on Google. Or let's say you decide you don't want to be just stuck to Google, you want to use AWS also. Well, AWS has something called EMR. Azure has something called HD Insight or Databricks, Azure Databricks, where the Spark code technically should work. It should be compatible, right? So you can make those choices if you use an open data platform. If you choose things that are native to a particular cloud vendor, like Bigtable, you have to think differently. You have to think about, well, how does Bigtable translate to something in Azure? Well, they have something called Dynamo. They're not compatible. You have to write special things to change your application from working on Bigtable to working on Dynamo. Whereas if you were using a technology like Cassandra, or even a managed database like cloud database for Postgres on Google Native, or Amazon RDS Postgres on Amazon, it's Postgres. You can use it either place and it'll be fine. I gave you the whole modern open data platform spiel because there's a reason, we put an emphasis on data ops and DevOps. Open data platform means you have to put it together. Google didn't do it for you. Amazon didn't do it for you. These things are available. And the way we put it together is through automation and DevOps and data ops. We're not going to talk about DevOps today, but that's a very important part of how we build open data platforms. We're going to talk about data ops. Data ops being how do we do ETL, ELT, ETLT, reverse ETL, orchestrating different processes. And Airflow happens to be one of those things that makes that easier. In fact, Airflow can even create infrastructure for you to do certain things. And we'll come to these other boxes later at another talk, but that's the thing. Because it's open, you lose out on the ability to just say, I want this from Google, and it'll make it for you. So Google has their own infrastructure as code. Amazon has their own cloud formation. Azure has ARM, and they have samples and examples of that. In an open data platform, you would probably use something like Terraform because it can work with all the different clouds. Airflow, as far as what we're going to talk today, it can do a lot of stuff. It's got 60 different modules or plugins. We're just going to talk about how do we use it to operate around Cassandra, data operations around Cassandra. And we're not going to maybe get into the Presto discussion today, but using Presto with Spark and Cassandra allows us to do even more with Airflow. Maybe I'll touch upon how that makes sense, but I'm not going to have a demonstration today. The other cool thing that we can use with Airflow and Cassandra is Amundsen. So Amundsen is a data catalog that actually can run on top of Cassandra via a Janus graph. But Amundsen is a data catalog that can take an inventory of all your data sources. And the way Amundsen actually keeps that metadata of all your data, your lineage of data, all that refreshed is by using an Airflow process, a recurring process to refresh its metadata. So, that's another thing. If you're using Airflow, you could elect to use one of, at least this data catalog already has directed acyclic graphs. And finally, the importance of automation, orchestration, and in general, is that if you have automations and orchestration for any process that's a push button, it means that new people can come and take part in the value your platform is providing and to start maintaining it much easier. And that's important from a management perspective. So Apache Airflow is an open source project. Apache Spark is an open source project. And you still need to write some code if it doesn't already exist, like a Spark Python app or a Spark Scala app or a Java or an R app. And all of that plus a Python DAG, directed acyclic graph. All that just means is there's a list of tasks that are organized in a way that it goes from left to right, if you can, meaning it has to go in one direction. So it's directed. And it's acyclic, meaning it's not something that's going to loop around and go indefinitely unless you want it to go on a recurrent cycle, right? It always goes in one direction. And that's a graph of tasks or work that Airflow is coordinating for you. And all of that together is basically a toolkit for data operations with Apache Cassandra. Now, you could take the same exact principles that we're going to talk about today and apply it to Databricks, where the data is all stored on S3. You could apply it to Dremio or Bigtable or BigQuery. I mean, you name it, right? Any big data operation, you could take the same principles and apply it. So Airflow, it focuses on automating repeated processes. You write these workflows in Python. You can have a recurring, a one-time scheduled, or an ad hoc process. You can even have things that are triggered by, let's say, some task that runs to update data in S3. It can detect that change and it can then run some task that subsequently does something with that data. And you can also, in the user interface, monitor and collect and look at logs. Spark, again, I'm not going to give you the, you can have a whole class on Spark, but it's a unified analytics engine, compute engine, you name it. It also has an internal DAG. It also has an internal scheduler, but it's a different type of scheduler. It's not the type of scheduling that we're doing with Airflow. It's about scheduling micro tasks for a much bigger task, for, let's say, millions of operations. And it provides this kind of API, 80 different operators that you can implement in any language. Well, not any language, but like Scala, Python, R, also Java and C# are available. It also has something called an SQL shell. So if you register a table using Hive syntax, say this table is backed by Cassandra, or this table is backed by S3 with Parquet data format, you can do SQL queries on data that is sitting in a non-relational big data system, and you can do queries against it, and you can do joins against those tables using SQL. And there's lots of other cool stuff, but again, Spark can run on a variety of things, including different clouds and things like Hadoop or Mesos or on Kubernetes. What we talked about earlier, Spark on Google Data Proc, that's basically, Yarn on Google Data Proc. Now, what I mean by bonus round here is that because we have some time, I can go through the nitty-gritties of what this looks like. So, in the world of let's say Cassandra or big data databases, there are many databases that now use CQL, okay? And CQL is a subset of SQL, right? So anything that I'm going to talk about here, you can use across Cassandra, DataStax, Scala, Yugabyte, or any of these cloud versions of those databases. So Scala Cloud, Yugabyte Cloud, Cosmos DB, AWS Keyspaces, Astra. You can use like literally this code that I'm going to show. You can use it against these databases. And cleaning data in Cassandra is very similar to cleaning data in any other big data system. Okay, if you're processing data, you can clean the data while it's getting processed, before it lands somewhere, or you can clean it after the fact, meaning you just store everything and then you do some processing after the fact. So in an ETL process, we would extract. While we're transforming, we would clean the data and we would load it somewhere. Cleaning it after the fact is really kind of like an ELT, right? We extract it, we load it somewhere, and then we transform and we clean it. And it could be beyond ELT. It could just be lots of data is coming in, and we don't have really a way to clean data from a, let's say, data governance or data retention policy with a simple time to live. So we need to have some sort of logic-based deletion of data. Or let's say we need to enforce GDPR and allow people to say, get rid of my data from here, right? And that type of deletion is not a simple, delete from this database where modified date is equal to or less than this, right? We can't do that. And that's where we need to have something more complex. In a relational database, we would just say, delete from blah table where this primary key is in this other query, right? So I want to delete these top 10 customers from the sales data. Well, this would work fine in SQL. It doesn't, we don't really get that ability. In Spark SQL, we can try to do that, and it can work in certain big data databases that are connected to Spark, but they don't work on all of them. So it's similar for some type of databases, but not all type of databases. So for example, this statement is only supported for Delta Lake tables, meaning they're Delta Lake Parquet format. It won't work on Cassandra. So when we're dealing with systems where we don't really get to just do a simple SQL statement to delete data, we may write some Spark code. So in this, what we're doing is we've made a function where we say, given this data set from Cassandra, select from this documents table, basically everything that meets this filter criteria. And the filter criteria could be a where clause, kind of like this. Where XYZ, or where date is equal to a certain, or less than or greater than a certain date. Okay, and we get that in a data frame. But then to delete the data that we want to delete, we're executing some CQL through this for each, and this happens in parallel. So it's not like it's going to do a big loop. It actually parallelizes the whole thing, and it can do a bunch of these deletes. The same exact operation, you can do it with Bigtable or with Dynamo. It's just your syntax will be slightly different, but the same thing basically applies, which is you do a select, you do a filter, and then once you figure out what you want to delete, you go through and you do a for each, and then you delete it. This is very useful. You copy and paste it and let people use this function by just saying delete this, delete this criteria from this table and from this key space. Very useful. But not everybody knows Spark. And maybe you want to give this utility to people that are in data analysis role. They're doing a lot of ETL, and you want to give them the ability to clean data without basically letting them have keys to the kingdom. And here's another example of like a dedupe function, which maybe the data analyst can figure this out, but they may not be able to do this. So you can also encapsulate some complex deduping logic and offer that to them. So how do we do that without giving them access to Spark and letting them copy and paste this method or include it in a library and use it? Well, we can wrap this logic with an Airflow DAG. And an Airflow DAG that can take inputs from the user interface in Airflow or from a table. So you can make an interface where you say, I request this query to be deleted from this key space and from this table, right? And somebody would say, okay, yeah, that makes sense. Go ahead and do it, right? So you can have some sort of approval mechanism. This is an example of us taking the where it accepts the source and destination data, and it basically takes that up, makes it into the format that Scylla Migrator needs, and it goes ahead and runs it. So when we wrap a complex process in an Airflow DAG, we can then share that process and give it to users via a user interface. Here's another one to delete data, right? Again, making it easy for people to say, I want this, customer's information to be deleted from this table. So I'm going to open this up in a second and just walk through the code. I don't think I'm going to be able to run the code for you. I could actually, but I think it'll make the thing go a lot longer. There are other demonstrations, things that you can run in your own browser. So for example, how to use Airflow to create a Google Data Proc cluster and an Astra cluster, how to use Airflow with DBT and Great Expectations, how to use Airflow with Cassandra and Presto, and also Airflow with Anant and Cassandra. So we'll take a look at the main example, which is ETL with Airflow and Spark. There we go. And you can always find this by Googling Cassandra lunch or data engineers lunch and seeing the latest listing of what we've spoken about. And they have links to GitHub and YouTube and SlideShare in our blog posts. So if you open up this repo, and I will put it in the chat so that we can drop it in the YouTube chat. It gives you a step-by-step, I'm getting copy commands from here, step-by-step instructions for how to do this. It can be opened up by just clicking on Open Git pod. And again, I'm not going to be able to walk through the Git pod, but I'll just show you what it ends up looking like in a second. So what we're doing here is we're taking data that is stored in this CSV file, for example. Right, well, it's kind of lots of data in here, so I'm not going to open it up. Maybe inside the Git pod we'll be able to take a look at it. So there's a CSV data set here. We also have a table structure that we have inside our, that we want to set up in Cassandra. We're not going to do that, but it's there. And there's a shell command that basically installs and runs Airflow for us. And we would do that while we're in the Git pod. The Git pod is a containerized containerized environment where it has all the information we're looking at here, all the code, all the data, and you can basically run this shell script to install Airflow on this container, right? And once it's running, it can run this DAG. Let me close this one here. And this DAG basically uses Spark. It starts up a Spark submit, right? Given a particular properties file for how to connect to that cluster, and it runs this Python file. Okay? In fact, it actually does 2 Spark jobs, one after another. Right? First, does load and write, and then it does an ETL job. So let's take a look at the properties conf here. So this is stuff that we would have to fill out, right? Which Cassandra cluster to connect to, what is the table name, what is the key space name, right? And the extract and load job, which is included in that DAG, right? There we go, right? This is the extract and load job. So you can have your own Python program for Spark that you've tested, and then you wrap it with basically Airflow using this bash operator. And there's also a Spark submit operator that works slightly differently if you were using, let's say, Databricks or Cloud Dataproc. And then also there's an ETL.py, right? So this is a simple PySpark application. Nothing special about it. There's nothing special about ETL.py and Spark DAG. These are just Spark Python applications. And we wrap those using this Spark DAG right here. I will show you what the Airflow interface looks like before we hop off. So if you look at the README, in fact, it's right here, right? It tells you how to get this running. So let's say we're going to skip the create data stacks Astra account. We're going to skip all this right now. I just want to show you the interface. So I'm just going to set up Airflow, copy this. It takes a second. And it's downloading a pretty recent version of Airflow. So sometimes I'm surprised I run it and there's some cool feature that shows up. And after it installs Airflow, because Airflow is web-based, in Git pod, it's going to ask us to expose some ports. So mind you that you don't want to be running Airflow without proper firewall in front of it, with username and password set up. So in this case, when we set it up, we're giving it a username admin, and I think it's going to ask me for a password when it comes up. One of the big vulnerabilities with Airflow was that people wouldn't give it username and password, or they wouldn't protect it behind a firewall. And basically, so there we go. I'm going to give it a very complicated password. You can guess what that is. And so we have an admin user. I'm going to make these public. And if we ran the Spark cluster, we would also see those ports, but we're not going to run a Spark cluster right now. Okay, so we got our admin. And there's a bunch of code examples here for if you want to learn. So XCOM is cross communications between DAG components. And I think this is still running. All right, it is running. It's just it's a container that's on a free system, so sometimes it's a little coming up. Maybe I'll go and open up. Oh, there we go. Okay, so here's an example where there's two parts of the DAG that need to communicate with each other, and essentially the code example, you can check it out just by clicking on code here. Here are the different tasks, and like for example, this is putting some data. But anyways, I'm not going to walk through this. This is an example DAG. You can see the code in here through the UI. You can't edit it here. It's not the point. But if we were to run this DAG, let's enable it. And the grid view will show us across different executions how long these things are taking. So I'm going to go ahead and play this. Notice, so it went ahead and ran once. I can trigger the DAG with or without extra configuration. So if you can imagine, if you wanted to customize the execution for this by passing it a parameter, you could do it through this. So for example, you could give it a JSON object. Now, there are better ways to make this where it's user-friendly, but this is one way. I'm just going to go ahead and run it again. And each successive execution of Airflow, it's showing the little parts on here, right? What is running, what is waiting, what is finishing. The green means it's a success. If there was some portion of this that failed, it would say up for retry or scheduled again, or it failed. So this first time, it took 12 seconds. The second time, it took 10 seconds. So we'll run it again, see if that's faster. And notice that the schedule for this says it's supposed to run once, and there is a no next run, because the metadata of this DAG doesn't tell it to do anything different. And you can check that out. Right? It says only do it once, right? And this is an example of an ad hoc job. I just want to run it when I feel like it. Right. Here's an example of something that runs on a daily basis. Right. So here's a data set. And this DAG is actually a part of a sequence of data sets that are connected together. And I think it involves S3. So it may, yeah, so it involves an S3 bucket. I don't have that configured. But what you can, this is a relatively new feature because I didn't see it when I was first learning Airflow. So here is a data set that is created as an output of two processes, sorry, an output of some process that takes these two data sets here and creates a data set from these S3 files. Then that outputs a S3 file here. And then these two can take and be dependent on the output of this one. So you can create these dependencies between data sets, and the schedule only runs because the data set got updated. So that's what a data set means. When you see the schedule, it says data set, that's what it means. Right? And it says the next time it will run is when a particular data set has been updated. So that's kind of cool. Here's one that would run maybe every minute. Or yeah, I guess that's what that is. I don't know. I'm not a cron expert. I always have to look at what that means. But I'm going to go ahead and unpause it. And I'm going to just go ahead and kickstart it. So note this other XCOM on the dashboard. I can see that it ran 3 times successfully here, right? And it would show us here how many are queued, how many are successful, how many are running, and how many have failed. And then this is basically even more granular, how many have been removed. So as the system runs all your jobs over and over again across days and months and years and weeks and minutes, in one view, you can see what's happening with your system. So for example, we ran this and it ran a few things successfully, but then it skipped something. So we want to see what happened. We can just go ahead and click on this. And note that it actually ran 1, 2, 3, 4, 5 times. Okay. And in a few times it didn't do something, it just skipped it. So you can have these conditional logic branches in your code that allow you to basically skip things if they don't need to be done. So for example, if somebody's deleting data from a table, right, that meets a particular criteria, and somebody else says, I want to delete this data, your DAG could be intelligent to say, you know what, this thing is already being done right now. Let's just skip the task. Right? Let's wait for the next time. Calendar gives you a calendar view of when things have been running successfully. Historically, you can see across the whole year how many failures. This is the measurement of how long things took. Right? Number of task tries. Right? You want to see how many retries did it take. This is the overall, landing time for basically different tasks have different landing times. The Gantt chart shows you this is a simple task. There's no this is it right here, right? This is the main task, and there was like one here and one here. But if everything is going well, you don't really have to go in here, right? You just maybe come here every now and then. The thing that's useful is that every time this runs, it is keeping an audit log. Okay. And I'm going to actually run one of the Spark jobs that it should have shown up here. Actually, it didn't because I have not copied it. Let's run this one because I know it's going to break. And so the benefit is that if you have a job that fails, you don't have to go to the computer that it was running on to figure it out. You can just go in here and it ran. Didn't have an issue. Interesting. Maybe it's a public data set. I doubt it. But you'd be able to see what happened, right? Was there an error? What was the error? Let me try another one. Kind of interesting. I'm trying to get it to fail on purpose. Let's see. No, I don't think it picked it up. I'll try one more here. So you may be wondering where the code is coming from. So this is the example directory. But if you wanted your DAG to show up here, you would copy it to a directory called DAGs, or you can configure where it is. And it just monitors it every 5 minutes. And if you put a file in there and it's not there, you can just say you can just say refresh and it will see the file there. So you can set up a CI/CD process so that if you trusted somebody else to write your DAGs for you for doing data operations, you could say, okay, make sure you commit your code to this Git repository and it will automatically get published here. Yep, sorry I didn't run the demo today. I did not have time, as I said, so we had one of our speakers couldn't make it today. I did not have time to test it out, so I didn't want to leave you hanging. Really amazing toolkit here, worth investigating. If you want to play around with it, as I mentioned, just go to the repo. You can walk through the example, just copy and paste it, and it should work for you. Right? So that's it. And with that, I will just take away. I'll give you some takeaways, and we can wrap it up. I use this plugin called Marvelous Suspender, which saves me memory, but sometimes it can take a long time to reload a simple deck. So some considerations, right? You don't have to run your own, you don't have to run alone. There are plenty of people, clouds that will do it for you. You can use open source Airflow by yourself against any of the cloud provider managed Sparks, or you can use any of the cloud provider managed Airflows with any variant of Spark, including open source. It's not like you have to use one or the other, right? You don't have to use Google Dataproc if you're using Google Composer or vice versa. Don't reinvent the wheel. If you're doing data operations with any big data, especially Cassandra, Spark is it. There are other ways, but for batch, Spark is it. And then a scheduler like Airflow, Apache Airflow with Python is very useful in repeatability of what you have come up with and giving it to people in your team, as in the form of a documentation or an automation. There's nothing better than saying, oh, you need to do this, go here, click this, put this parameter for what you're trying to delete, and press run, right? And that's it. Thank you. If you're interested in our free stuff, just go to our Anant.us site and find all the resources we talked about, such as the videos, the code examples. Our blog will have links to the deck and to the code. And then you can also, if you're interested, see if we can help you out. Excellent. Well, thanks. Looks like there's no questions. You guys have a wonderful rest of the day, and we'll see you next time, same place, same time.